Hello everyone, welcome back to Untitled Engineering. On this lesson, I want us to look at binary. Binary, it's a counting system, just like any other counting systems that we know. And to understand how binary work, we are first going to look at the counting system that we know, called the base 10. It's called the base 10. Why? Because we have 10 symbols to work with, starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is why this is called the base 10 counting system, aka decimal. We have 10 symbols representing from 0, these represent actually nothing. And then going to 1, this will be 1. This will represent 2 up until we get to what? To 9. This will represent 9 things. So from here, to represent 10 things, what we are going to do, since we can tell that 9 is the maximum symbol that we have on this counting system. If when we get to 9, we are going to roll this back to 0 and then add a 1 on our left hand side. And then we start afresh. 1, it will be 1, 2, 3, 4, up until we get again to 9. We roll this back to 0 and then we add a 1 on our left hand side. Up until we get to 9, 9. We can tell that this is 9 and this is 9. Both are the maximum symbols that we have on our base 10 counting system. Meaning from here we are going to roll them back to 0 and then add a 1 on our left hand side. And each and every number that we add on the left hand side will represent an increasing to the power of 10. So it will be like this: 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, and it goes on and on. On the binary counting system, we only have 2 symbols, which is a 1, it's a 0 and a 1. And those are the 2 symbols that we have. So now to count using the binary system, we're going to start with a 0, which is representing actually nothing. And then we go to 1. 1, it's 1. Same 1 as in the base 10 counting system. And then to represent a 2, remember, now we are at 1. 1, it's what? It's the maximum symbol that we have on our binary counting system. The maximum symbol on our base 10 was 9. And what happened when we got to 9? We rolled it back to 0 and then added a 1 on our left hand side. Same thing happens here. We are going to roll it back to 0 and add a 1 on our left hand side. And then from there, we start fresh. It will be 1, 1. Now we have 1, 1, which are maximum in terms of the binary counting system. What did we do when we had 99? We rolled these 2 back to 0 and added a 1 on our left hand side. Same thing will happen here. Not to say 1, 1 on binary is equals to 99 on our decimal. I'm just pointing out what do we do when we get to the maximum symbol of that counting system. Actually, let me erase this. So from here, we are going to roll them back to 0 and add a 1 on our left hand side. Then from there we are going to start afresh. 1, 0, 1. 1. From here it will be 1, 0. It's the same as having 1, 0, 9. From here we are going to say 1. We roll this back to 0 and then we add a 1 here. It's the same thing here. Not to say this and these are equal. No, I'm just pointing out how do we do, since this is the maximum and this is also the maximum. So I'm going to erase this again. And then from here we're going to have 1, 1, 1. And then maximum, maximum, maximum. We roll them back to 0 and add a 1. From there we continue. 0, 0, 1. 1, 0, 1, 0. We roll this back to 0 and then add a 1 on our left hand side. and it goes on and on. And this, in terms of the base 10 counting system, this will be 0, this will be 1, this will be 2, this will be 3, 4, 5, 6, 7, 8, 9, and 10. This is the binary counting system, the binary version of 0 to 10. And this will be the base 10 version of 0 to 10. How then can we convert from binary numbers to decimal numbers? So the first thing that you need to know is that since we are only using 0 and 1, we are only having two symbols on the binary counting system, meaning each and every number that you add on the left hand side will be an increase to the power of 2. If it's 0, 1, 0, 1, 1, 1, you're given this number and then you're asked to convert it to the decimal or the base 10. Take this number and say 0, 1, 0, 1, 1, 1. Now, a 1 will represent that we are to take that number to consideration. And then a 0 will represent that we have to ignore that number. What do I mean by that? If we are asked to convert this to decimal, what we are going to do is we're going to say 32 plus 16, because there is a 1 and there is a 1 here, plus 8. We're not going to add 4 because there is 0 here, but we are going to add 2 because there is 1 here. We are not going to add 1 because there is 0 also here. And then from here, we are going to add all of this. 32 plus 16, that will give us 48. 48 plus 2, that will give us 50. 50 plus 8, that will give us 58. And that is how we convert from binary to decimal. Let's do another exercise. We are asked to convert this number 1, 1, 1, 1. This is binary. We have to take it where? To decimal. First things first. This will be 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 4. Actually, let's just write the numbers. This will be 1, 2, 4, and 8. Now, we are going to start with 8 plus 4 plus 2 plus 1. What is 8 plus 2? That will give us a 10. 4 plus 1 will give us a 5. 10 plus 5 is 15. So to represent a 15 in binary, we are going to write 1, 1, 1, 1. So let's say we are given another number, 0. It's 1, 0, 1, 0, 1, 0. It will be 1, 0, 1, 0, 1, 0. We are going to divide them. This will be 1, this will be 2, this will be 4, this will be 8, 16, 32. It will be 32 because there is a 1. We do not have a 16 because there is a 0 there. Plus 1, which this one is representing 8. And then there is a 0 here. We are not going to take that one. There is a 1 also here. We are going to put 2. And then this will be equals to this, and this will give us a 40. and it's 42. And this is how we convert numbers from binary to decimal. Let's do a last one. So let's use 1 0 0 0 0 1 1. Let's use this. So first of all, we have to divide, we know. This will be 1, this will be 2, 4, 8, this will be 16, 32, and this will be 64. So now let's convert this binary number to a decimal. We are going to have 64 plus, we do not have a 32 because there is 0. We do not have a 16 because there is 0. We do not have 8 because there is 0. We do not have 4 because there is 0. It will be 2. There is 1 there, plus 1, there is also 1 there. Then 64 plus 2, that will give us 64 plus 2, that will give us 66, 67. Therefore, it will be 67.